Assalamualaikum warahmatullahi wabarakatuh and very good morning to Dr. Hafiz and my fellow friends. Today we will present our assignment 1 in process control system.
First, this assignment we use the first order plus this time FOPDT models, and to develop the FOPDT models we need to determine the K, tau, and delta based on the open loop experimental data. Draw the inflection point line, and next draw the horizontal lines for the minimum value. Draw the vertical line and zero time, and draw the vertical line and intersect line step 1 and line step 2. And the delta is the time between this line and this line. Find the relationship between the time and x-axis sketch, and find the delta in the second. Draw a horizontal line for maximum value and minimum value. A is the graph magnitude between the maximum value and minimum value. And next is to find the relationship between the temperature and y-axis sketch. Draw the horizontal line for 63.2% of output response and touch this line. Determine the time constant tau also in the second, and the formula process get is K equal to change of output response A minus by change of input. The A is the maximum value minus minimum value, and the P is given for the assignment title. 5 volt minus zeros is given by question. This is a step-by-step calculation based on the formula. And finally, we get the FOPDT models is G equal to 40.584 exponent 154.7 second divided by 916.3 second plus 1. To determine the PID parameter, we use the two rules. It is the Jingles-Nichols-Dunning rules and Chorlton-Dunning rules. All is the same, it is different, but the different formula only. To get the Kp, Ki, and Kd, just follow the formula and insert the value into the simulation PID control using the MATLAB software. The back of calculation anti-Vital sketch also use this formula to calculate.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Aminuddin bin Awaka. So in this project specifically, I use Chu-Hen-Chun methods to tune PID controller. It has a 3 parts: professional, integral, and derivative, to control accuracy and stability of the system. So after setting up the system, we run the system, then double click the scope to observe the output waveform. This is our output waveform using Chu-Hen-Chun's methods. So next, in command window, we extract the output data here and set point data, then we paste them into Excel platform. So here the value of A represent the output data, then the value of B represent the set point data. We can see here this waveform looks like based on the given data. So next is we must to take the output value from 2500 to 5000. So then paste here together with the set point here, and the value of C represent the error calculation, which from A1 minus B1. So the waveform demonstrates slightly decrease based on the provided data. So next, we sum up the errors value to obtain the total value. So we get total error is 2.13 times 10 the power of 1. Then from the answer, we divide it by 2500. So the answer is 21.3. So next, we return to command Windows. To analyze the output waveform, we create the file name is output. Then in command window here, we can use command which is step info. Step info, open the bracket, and then we use file name is output and close the bracket. Here is output file, and then enter. So we can see here, this is our output waveform of Chilhern tunes. So we can see here, this is a rise time. We have 850. Transient time is 2.9561, and settling time is 2.9209. Settling mean 135. Settling max is 206. Overshoot is 37. Undershoot is 0. Peak is 206, and peak time is 2136. So before this, I have explained how to get value of mean square error between 2500 to 5000. So now I will explain about the analysis and discussion for each PID tuner. So we can see here, the table provide a comparative analysis of ZN and CC PID tuning. So both methods are achieve rise time around 850 seconds. Their overshoot value are beyond 6%. Their settling time are too long, which ZN is 31.171 second, and CC is 2920 seconds. Additionally, the mean square error for both greater than the specification given, which is 1.5 times 10 minus the power of -4. So in conclusion, while both ZN and CC tuner provide a functional control system, meanwhile they not meet the specification requirement by duri hitam holding. The robust PID result for both Ziegler-Nichols and Chilhern tunes tuning shows significant improvement and mostly meet the specification requirements. The overshoot is below 6% limit. ZN achieved 2.93% and CC slightly higher at 4.59%. The settling time is also improved, which ZN is 1352 seconds and CC is 1179 seconds. So both under the requirement 1650 seconds. Next, rise time and transient time are faster compared to original PID tuning. So however, the MSE for both is 0.0492, which still above the specified limit of 1.5x times 10 power by -4. So in the conclusion, the robust PID controller, the overshoot and settling times meet the criteria. So therefore, the objective of this assignment to compare the performance of different PID tuning has been successfully achieved. So that's all from me. Thank you.